Okay, so this is related to your physics again. So I would like to elaborate a little bit more. So for the substance X, the magnitude of the value of delta H fusion means solid to liquid, is less than the magnitude of the value of the vaporization. So delta H enthalpy of vaporization is greater than enthalpy of fusion. So X melts at temperature T1 and then vaporizes at temperature T2 upon heating, which diagram below best depicts the variation of the temperature with time when a solid sample X is heated at a constant rate. So first thing need to understand, it is heated at a constant rate. Okay, so the rate is constant. And then we need to consider about the variation of the temperature. So when you have the solid, you heat it. So the temperature is increasing of the solid. So at one point, there is a phase change. Okay, in Sinhala we say avastha viparyasayak wenawa. So here there is a phase change. So phase change is from solid to liquid, which is called the melting, and from liquid to gas, which is called the boiling, right? So when solid to liquid is converted, you need to understand what is happening here with the temperature. When there is a change, a phase change from a solid to liquid, there is no temperature difference. So if you can remember your physics here, so basically what is going to happen here, so okay, so let's take for an example, let's take a compound which is that is going to heat from temperatures. So you heat it, so it will increase at point where your melting happens. The temperature will be remaining constant. This is T1, and then you heat again, and again at the second phase transition, your temperature will be T2. Okay, and furthermore, you can heat it furthermore. I don't mind it. Okay, so when you have this solid, here is solid liquid equilibrium, and then here you have liquid, and here you can have liquid vapor equilibrium, and you have vapor here. Okay, so this is what normally happens. The point that they have given here is the vaporization, enthalpy of vaporization is higher than the enthalpy of fusion. What is it mean? Means the amount of heat we should give to vaporize is very large, so that you need to heat for a larger period of time. Okay, so here this is time. So the time difference between these two, okay, this time should be very larger than this time, because delta H vape is higher than delta H fusion. In fact, if you know about your physics, you should be automatically understand this gap should be very large, because if you want to calculate heat here, you can use MC delta theta. Okay, and if you want to calculate heat here in the phase change, you need to use H is equal to ML. Here L is enthalpy of fusion. We say L because of it is like the specific heat capacity here that we use here C. But here, since there is no temperature change, you cannot use MC theta because it will give a zero answer. But in fact, the compound absorbed heat without any change in temperature. So this is called latent heat of fusion. We use L. And here again, we use here delta H is MC theta, MC delta theta. But here this C and this C is totally different. because here this is the specific heat capacity of the solid, and here this is the specific heat capacity of the liquid. And here again we use H is equal to ml. This is latent heat of vaporization, because these two are different. And actually the main reason why this time difference is smaller than this one is, here the latent heat of vaporization is very large for the liquid compared to the solid here. Okay, don't forget that. And then for the vapor, again you can use MCT delta theta, and again for the vapor there will be another different specific heat capacity. Okay, so try to understand this entire picture. This is what we normally learn in physics also. Okay, so this question is actually not related to chemistry. It is actually related to physics. Okay. So based on the answers given, so there should be two phase changes from solid to liquid and liquid to vapor. So these are not our considerations. So we are only dealing with these two. And since the vaporization is larger enthalpy, so it should have HML. So if you are using H is equal to ML here as well as here. So to have this higher amount enthalpy of variation, the rate of heat of vaporization should be larger than latent heat of fusion. So that is what normally happens. So this is very large. So this is the acceptable. Okay. So this is not chemistry, this is physics. Little bit of chemistry.